Hi ladies, this is lesson 8.5 and this lesson deals with surface area. So in this lesson, we're going to look at finding surface area of solids. So we're going to think logically about what makes up the surface of these particular solids. So here are some vocabulary terms that we have for this lesson. Now on your note sheets, you'll see these also all defined for you. So this is what your note sheet should look like. So surface area, we're only looking at the area of all of the faces or the surfaces that enclose the solid. So it has nothing to do with how much fits inside. It's just if you were to paint the object or if you were to cover it in wrapping paper or just cover the surface, how much area is on the surface. The bases are the bottom face of the solid. So in a prism, there are two bases, one on the bottom here. This would be a base. And then you would have the same base on top. In a triangle, in a pyramid, you would just have one base. The top is just a point. And then the lateral faces are the sides. So in a prism, if you look at all of these lateral faces, this is one lateral face right here. Those are all rectangles. In a pyramid, the lateral faces are triangles. The slant height is not the height of the solid, but it deals with pyramids or cones. But the slant height goes from the tip to the perpendicular to the edge of the edge of the base. And then a regular pyramid is a pyramid with a regular polygon base. So in this case, this pyramid is a pentagon, has a pentagon base. So this would be a regular pentagonal pyramid. And in the second one over here, we have a square pyramid. Okay, so here's the slant height, that's L, whereas the actual height, H, goes from the center of the base to the tip of the pyramid. All right, earlier last semester, we looked at nets. And if you remember, a net is the two-dimensional figure that forms a solid. So if you unfold a box, you would see its net. If you laid it flat, you would see its net. You could do the same thing with like soup cans or any solid figure. So let's look at this net to the right. Each side length has a length of 8 centimeters. And these are all squares, it says. So this is 8, and that's 8. So each side of every square is 8 centimeters. So the question is, what's the total area of this shape? Well, we can determine that one of these squares is 64 centimeters squared, and we have 1, 2, 3, 4, 5, 6. So we have 6 squares that each measure 64 centimeters squared. So that gives us a total area of 384 centimeters squared. So now if we folded this up, if we folded it into a solid figure, this would form a cube. So that's exactly what we're doing when we're looking for surface area. We're looking for the area of each side of a three-dimensional object. So when we do this, we're going to first draw and label the figure of the solid as if we cut it apart along its edges and laid it flat. Again, like we unfolded a box and we laid it flat on the ground, how much area does it cover? So we're going to calculate the area of each face. and then we're going to add those all together. So looking at this regular prism, this is a rectangular prism. So we're going to look at the faces. So we've got this one, this rectangle that measures 3 by 6, which is the same as this rectangle back here. So we have two faces that are 3 by 6. And then we also have this face here that measures 3 by 8, which is the same as this one here. So we have two faces that measure 3 by 8. And then lastly, we have the top one, which is the same as this bottom face. So we have the top and the bottom, which are the same, the left and the right, which are the same, and the front and the back, which are the same. So the top and the bottom, we have two of those, and they measure 6 by 8. So we're going to find each of these faces. So 3 by 6 is 18, and 18 times 2 is 36. And then secondly, the left and the right one, they're each 3 by 8, that's 24. 24 times 2 is 48. And then lastly, the top and the bottom one. So 6 by 8 is the top, that's 48, and we have two of them, so that's 96. So then we can add those all together. So 36 plus 48 plus 96 is 180, and these are measured in meters. So the surface area of this rectangular prism is 180 meters squared. So try this one on your own. Pause the video while you work, and you can unpause for the solution. All right, here we have two sides that are each 5 units, and then one side that goes from the front to the back that's 4 units. So the top and the bottom and the left and the right are all 5 by 4. So here's the bottom, here's the top, here's the left, and here's the right. All of those sides are 5 by 4. And then the two that are 5 by 5 are the front and the back. So 4 that are 5 by 4, that's 80 units squared, and 2 that are 5 by 5, that's 50 units squared. So the total surface area is 130 units squared. Let's look at a different shape. This is called a cylinder. A cylinder has a circular base and top. And if you imagine this as a can of food, the label covers all the way around. So the label of the food would go all the way around here. If you've ever peeled a label off of a can of food, it's a rectangle. Okay, it covers the whole front of the can, all the way around the can. It doesn't cover the top and it doesn't cover the bottom, but it covers around the can. So if we think of what shapes make up the cylinder, we have a circle for the top, we have a circle for the bottom, and then we have a rectangle for the side. Now these two circles, we want to find the area of the circles. So the area of a circle is pi r squared, and length times width, or width times height, or however you describe it for a rectangle. Now pi r squared, we need to find the radius. So right now we have this distance, okay, that covers across the circle. So in this case, our radius is 5 inches. Okay, the radius is half of the diameter. And then if you think of the length of this rectangle, we're going to call the width 12. We're going to say this is 12. Okay, that's how tall it is right here, 12 inches. But the length of this, of the label, it has to go all the way around the circle. So how do we find that distance around the circle? The length is the circumference. Which is 2 pi r, or pi times diameter. Okay, so in this example, let's look at the area of the circle. So the radius, or the area of the two circles. So we have two circles that are exactly the same with a radius of 5 inches. So 2 times 5 squared times pi. So 2 times 25 pi plus length times width, where we said the length was the circumference, which is pi times diameter. The diameter is 10. And that's multiplied by the width, or the height. So in this case, we have 50 pi plus 120 pi, which is equal to 170 pi inches squared. And you can calculate that out if you want. It calculates out to approximately 533.8 inches squared. All right, try this one. You can pause the video while you work, and then you can unpause for the solution. All right, so here's our cylinder, and in this case, we're given the radius. So we have two circles that are exactly the same. Pi times radius squared is the area of each of those circles. So that adds up to 72 pi. And then our rectangle that goes around, we need the circumference. Okay, the circumference is the length of our rectangle. And then the height of our rectangle is 15 units. So 72 pi plus 180 pi is 250 pi. So that's 250 pi units squared, which is approximately 791.28 units squared. All right, now let's look at the surface area of a regular pyramid. If you think of a regular pyramid, you have a regular polygon base, and then you have a whole bunch of triangles that come from the base to the tip. So a surface area of the regular pyramid is going to be all of those triangles that are all exactly the same, that have a base. Each triangle has a base that is equivalent to one of the sides. So the surface area of a regular pyramid is 1/2 base times height. But in this case, we're going to refer to height as slant height because that's the height of the triangle. So we refer to slant height as L. So 1/2 base times the slant height of the pyramid, which is the height of the triangle, times however many sides there are. And we're going to add that to the area of the regular polygon base. So if you remember, the area of a regular polygon base is 1/2 times the number of sides times the apothem times the side length, which in this case the side length is this B. So if we want to simplify this a little bit, so here is these are all of our triangles. And this is our base. So let's just simplify this a little bit to get the surface area of the entire pyramid. So if you remember from algebra, we can factor. So let's factor a little bit. We have 1/2 in both terms. We have a B in both terms. And we have a number of sides in both terms. So 1/2 times B times the number of sides times whatever is left, our length and our apothem. Right, so here's our formula for a surface area of a regular pyramid. Now, just to simplify a little bit more, B times N, that's the side length times the number of sides. That's equal to the perimeter. So we can say that the area of a regular pyramid is 1/2 times the perimeter times the slant height plus the apothem. So that's the formula that we're going to use, but you should understand how it's broken down. So again, we got that 1/2 P times the group L plus A by factoring and simplifying. And that's the formula that's on your note sheet. Okay, so where P is the perimeter, L is the slant height, and A is the apothem. Now we're going to do something similar with the surface area of a cone to get that formula. So in the surface area of a cone, here's our cone. Now if you unfold it, it has this weird triangular shape, but we can rearrange those little pieces. We can cut all of those into little slices. And when we do that, we have a rectangle. So here's our length and here's our width. Okay, so the surface area of a cone is a circle, and this triangular shape with a curved base, which is the same as our circle, plus this rectangle, where our circle's area is pi r squared, and our rectangle's area has a base of pi r and a height of L. So if we look at this surface area of a cone, we're saying pi r squared plus pi r L. Again, we can simplify this, and we're going to do that by factoring. So if you look at both of these terms, they both have a pi, and they both have one r. Pi r. So we can factor out that pi r, and we're left with r plus L. Okay, so that's how we got that surface area of a cone. It's pi r squared for the circle plus pi RL for that rectangle. And that's equal to pi times r times the group r plus L. Okay, where r is the radius, and L is the slant height. Right, so let's go back and do a couple examples. For this example number 4 that's on your note sheet, the base of the has a regular pentagon, so that's 5 sides. With an apothem approximately equal to 11. And the side length is 16, and the lateral edge is 17, and the height of the face, or the slant height, L, is equal to 15. Okay, so first of all, looking at this, we don't actually need that height of the lateral edge. That's this part right here. We don't need that in order to solve this problem. So we're going to use the surface area of the regular pyramid, which is 1/2 times the perimeter times L plus A. So we know that it has 5 sides and each side is 16 units. So with 5 sides and each side is 16 units, that gives us a perimeter of 80. So we have 1/2 times 80 times our slant height, which is 15, plus our apothem, which is 11. So 1/2 of 80 is 40. 40 times 26. That's going to be our surface area. So 40, oops. 40 times 26 is equal to 1040. And we don't have units, so we'll just say units squared. Right, and then the last example, let's look at the surface area of the cone. So again, we have a circle and we have a rectangle where the rectangle is pi r times L. So the circle, pi r squared, or we could use the formula, which is pi times r plus L. Okay, so we know that the radius is 5. So pi times 5 times 5 plus 10. And that's going to equal our surface area of the cone. So pi times 5 times 15. And 15 times 5 is 75. And this is in centimeters squared. So you can leave it at 75 pi centimeters squared, or you can calculate that out, and that's approximately equal to 235.5 centimeters squared. So please jot down any questions you have for this lesson, and we can go over them next time I see you in class. Thank you.